Hello and welcome to the How to Carnivore podcast. I'm your host, Simon Lewis, and you're tuning into the Plant-Free MD series with Dr. Anthony Chaffee. Dr. Chaffee is a surgeon, nutritional researcher, and former pro rugby player. He's been strict carnivore for 3 years and an on and off carnivore for more than 20. Dr. Chaffee looks and feels like a real-life superhero. If losing fat, building muscle, finding focus, and getting the most out of life is important to you, you're going to love the Plant-Free MD series.
Hello, and welcome to another episode with the Plant-Free MD, Anthony Chaffee MD. Today, we've got a very important topic. For a while now, we've spoken about the nutritional benefits of eating an animal-based or carnivore diet. But today, we're going to talk about the environmental impact. And we're going to dispel a few myths that are being circulated in mainstream media. And we're going to explain why eating meat is actually the best thing you can do for the environment. So, Anthony, welcome.
Hey, thank you very much. Good to see you.
Yeah, likewise. So we're constantly being told that cow farts are destroying the planet. You and I both know this isn't true. Let's dive into it a little.
Yeah. So, I mean, the first thing you have to remember is that, cows and other animals are not just making all of these chemicals de novo. They're not they're not alchemists. They're not creating new substances. So, all of this carbon, methane, and so forth, these are all actual nutrients and so forth that used to be a plant and that the animal is actually recycling and is recycling back into nature. And this actually benefits the planet, benefits plants, because plants and animals, cohabitate and co-evolve. So the big grasslands all evolved with ruminant animals that were eating them and recycling these nutrients and so forth. So this is where urine and feces are used as manure, and this helps plants grow. And this is what keeps the soil full of nutrition for the plants. And it's the animals that recycle that methane as well, even CO2. I mean, let's think about this for a second. Anyone who's taken elementary biology knows that plants breathe CO2 and we breathe oxygen, and we release CO2 and they breathe CO2 and release oxygen. They do a bit of both actually, but there is a symbiosis. We're each recycling each other's nutrients for life. And cows are part of that, deer are part of that, sheep are part of that, all the different sort of animals are part of that. And in fact, when you start removing animals from areas, this is actually where you start seeing deserts start to form as opposed to the other way around. And so people like, Allan Savoury have been for 40 years taking large herds of animals, bunched and moving like you'd see in nature, so that they don't overgraze, so that they're leaving a lot of manure in concentrated areas. And they actually revitalize deserts, actual deserts. There's one example of this in Patagonia where they took his methods and took, I think it was 20 to 25,000 head of sheep, moved them through deserts in Patagonia. And within 1 year, they had a 50% increase in vegetation. So, and that was just 1 year. And so, he has a YouTube, a TED Talk on YouTube, and his own website and books that he's published and textbooks that he's published, all on this, showing the pictures of all of these reversed deserts. And see like a ridge line of, like a fence or something like that. There's this one farm and there's this other farm. One did Savoury's method, the other didn't. One turned, green and verdant, and the other stayed a desert. And so this is being repeated by God knows how many people all around the world in regenerative agriculture, and they're all seeing the same results. So this is a repeatable, demonstrable event.
Two things that I want to sort of highlight that you've brought up. The first one being that animals aren't creating anything new. So you sort of spoke about that at the start. It's like if there's methane coming out of the cow, or if there's carbon coming out of the cow, well, they're getting that carbon from somewhere else. And in the natural cycle of life in nature, everything gets recycled. Nothing new is getting made. Everything has its place. So that balance is really important. And also the biodiversity. I think a lot of people don't realize that when you have a crop with just the one plant going all the way through it, you're going to have to kill off a whole heap of other things that would naturally be going through to create balance in the ecosystem. just to get that one perfect crop. So what you really want is animals, bugs, microbiome, plants, all live cohabiting, the same fields and the same areas.
Yeah. Well, and that's the thing, that's the other side of the coin that people don't always talk about, which is, what's the alternative? So we're just going to grow crops. Okay. But what does that do to the environment? If we are concerned about CO2, and I think that has a big question mark on it, because this is actually beneficial to plants in a lot of regimes. And there are, plenty of Nobel Prize winners in physics, and, people like, Freeman Dyson, who's one of the greatest mathematicians in the last few centuries, who actually made these models, who made these computer models and so forth to actually study this sort of thing. And they talk about the limitations of these computer projections and so forth, and what we actually see and so forth. So it's not as cut and dry as all that. But let's say that CO2 is a really, really bad thing. Well, plant agriculture in America accounts for more CO2 and greenhouse production than livestock does. Simple as that. And so if you're going to replace, cows and meat and so forth, you're going to replace it with plants, would actually produce more more CO2 and so forth. And if that's a problem, then that's a significant issue in the environmental discussion. So the other thing is, how do we make crops? Like you say, you get some monocrop. Well, what you have to do is you necessarily have to destroy an entire ecosystem. You have to kill every single plant and every single animal that lives in that ecosystem, and you have to tear up the land and grow a single crop. This is actually bad for the soil. We lose quite a lot of topsoil every year through to this, because you're tilling ground, which is actually quite bad for the ground. It's very bad for the topsoil as well. It loosens it up. Now the wind can pick it up and take it away. The rain washes it away as well, washes away the seeds as well. And you have to replant your whole field sometimes if you get a heavy rain right when you've tilled the ground. This isn't a small issue. Remember back to the 1930s-ish and 1930s with the Dust Bowl era in America. The middle of America, which was one of the most fertile areas of the world prior to this, was now turning barren, and all the topsoil was getting ripped away. You had massive dust storms, locust swarms, and so forth. They were just eating out all these crops. It was like a Bible story, something out of Exodus. And people really thought that that's sort of what was happening. And then they realized, this is from crop farming, and they had rows of field tilled in straight lines for 6 miles, and the wind could just pick it up in that direction and just blow it all off, or the rain could wash it away. Now you have these scallop patterns to the crops. If you notice, if you drive by a field, you'll notice that you have these scallop patterns. They're like in circles instead of straight lines. And there's other techniques and so forth that they use to mitigate this. And that's the only reason that the middle of America didn't turn into another Sahara Desert, which I believe is likely caused by early farming as well. It's man-made. We know it's man-made. It wasn't in existence, a few thousand years ago when the
Sahara Desert is man-made.
Yeah. I mean, that's what it suggests, because we look at there was studies looking at soil samples in Egypt under the pyramids and the Sphinx in the 1990s, and they said, it was like, were these built in deserts? Were these always desert people? And they found, well, no, actually, this soil composite is much more in keeping with what we would see in jungles. So these were jungle pyramids. This was a jungle Sphinx, and
wow.
And so but this is where this is the breadbasket of the ancient world, right? So these big crop farming and so forth happened in Samaria, which is sort of modern day Iraq. You have the Hanging Gardens of Babylon, one of the 7 wonders of the ancient world. And, you read Gilgamesh, and it talks about these verdant fields and these deer and antelope running around eating grass, and cedar forests and all these sorts of things. That's modern day Iraq. I don't think there's a single cedar tree left,
it's like a barren desert there now.
Yeah, quite literally. And then you get Egypt, which, they had, as I learned as a kid, maybe other people did as well, that the reason that they were so fertile and productive in their farmlands was because the Nile River flooded every year, and this deposited, brought new deposits of soil and silt and brought nutrients to the soil. But what does that mean? that means that you necessarily have to replenish the nutrients every year because they're going away. They're going up into the plant itself, and because there's no animals going through eating down the chaff and leaving manure, it's not getting replenished. But it is if the Nile River floods. But what about areas that don't have a Nile River and they don't realize that this phenomenon is necessary? It turns to desert. It becomes barren. They crop for several cycles, and then that's it. There aren't enough nutrients to grow these plants there anymore, and they go to the next spot and go to the next spot and go to the next spot, and these places just turn to dust, and they don't have animals coming through to regenerate it, and so forth. And this is part of desertification.
I think we should highlight that role that the animals play. So, like, say if we talk about America, back before, say, 1700s, where you had millions of bison that were roaming through Central America. And they would move in large herds. They would eat the grass, and then they'd move on. And then the grass had a chance to regenerate and grow and maintain strong roots. And the role of those cows, their hooves would create little divots in the ground so that water could capture. They would disturb the land so that things could grow better. They were an integral part of nature, of the cycle of things. They play an important role.
Yeah. Well, that's the thing, these grasslands and these large ruminant animals co-evolved, they grew up together, as it were. And so they're necessary for each other. And so when you get, grass grows to a certain length, and then it starts growing, slower, and it sort of gets, just sort of gets to the end of its growth cycle, and it just sort of stays stagnant. But if you eat it down to a certain length, it'll actually grow, something like 4 times as fast. And if you eat it down too much, you really hurt it. And this is where, overgrazing. This is where the theory came from. It's just like, oh, well, we have these paddocks and we overgraze. Animals are destroying the land. Well, that's just when you lock them in a cage and don't feed them anything properly or move them to another pasture. That can happen because they're starving. They're just going to eat whatever the hell is there. But when they're moving around in nature, they just keep moving because they're defecating and urinating on their food source. So they're not going to eat it down to nubs because they have to keep moving, and they have to keep migrating to new food sources, and to get away from predators, they're going to stay tight and bunched. And so the middle of America was extremely fertile. When we first started exploring west, we saw that these grasslands just went forever, and the grass was crazy big. So there are accounts of the early explorers saying that the grass was something like 9 feet tall.
Wow.
In America, we think of that, like India or something like that. But this was in America, and they described how they could tie the blades of grass above their horses' heads as they were riding through. And there were not only millions, but hundreds of millions of buffalo, and then hundreds of millions, if not billions, of other large ruminant animals and other just smaller animals. Obviously.
Dude, it really was a paradise, wasn't it?
America. Yeah, it really was described that way when you had people exploring out west, and they get into the mountainous regions. And normally we think you go to the mountains to go hunt. Now that was the exact opposite at the time. They said that they were in the mountains. They're like, oh, thank God we're getting back into the plains where just game is just so abundant. And it's like a nature video out in the Serengeti or something like that, with just, herds of gazelle and zebra and this, you're just seeing all these just animals everywhere. Well, that was the middle of America, and these massive grasslands, and just hundreds and hundreds of millions of animals, billions of animals really. And so they just go out there and you just see, bang, 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 bang. I mean, these things were so abundant that, like Wild Bill, Buffalo Bill, Wild Bill Hickok, when they were sort of eradicating the buffalo to wipe out the food source of the Indian nations that they were fighting at the time.
I actually saw a photo of that we should share. There's this photo where it's like a stack, like 5 meters high, of buffalo skulls.
Oh God!
One of the most devastating things you've ever seen.
Yeah. So they were just going on trains and just shooting these things from trains, just bang, 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 bang. And so they were in that close of proximity to just anything, any sort of human endeavor. There were just tons of these things. They were the ones that you were keeping the grasslands as they were. And so the idea that animals in fact are destroying that land, it is against the observable facts. And and against reality. So it's animals that actually, like we say, revitalize the nutrients and so forth. Because like I was saying, when we farm, we are losing topsoil. We don't realize this, but we're losing about 17.5 billion tons of topsoil a year. That was the figure in 2017 that I saw. That's an area the size of Kentucky, the state in America. That's a limited resource. It takes about 500 years to grow half an inch of topsoil, like a centimeter. So, this is a finite resource. Everyone talks about oil and so forth. Like topsoil is going to run out a lot sooner than oil. And in fact, there's thoughts that oil is actually being, steadily reproduced and so forth from tectonic plates sort of folding over each other and crushing these little, carbonaceous, skeletons of little plant life, of animal life and so forth. And they've reproduced that in the lab setting and so forth, making these complex hydrocarbons and so forth.
And look, we can't live without topsoil because that's how we get quality, nutritious food. So,
well, but it also is going to turn these things into deserts and barren wastelands, and that's going to spread. So one of the reasons that these things turn to deserts as well is when there's not enough animals. Okay. So you get these grasslands, you get these things growing up, and then they sort of become somnolent and they just sort of are stagnant. Well, the problem is that now all the new seeds for the next year's growth are getting blocked out from the sun because nothing's eating these things down to give the new life a chance to grow. And so they sort of grow up, don't get enough sun, and they die. And now you have this sort of dead, dying bush or plant or, grasses and things like that aren't growing, that aren't doing anything. But they are just there and they're taking up space and blocking the sun. And so you need animals to go through and eat these things down just to give the light of day a chance to get down to these new sprouts. And like you say, when the animals come through, they dig in with their hooves, and this actually creates little basins for the rainwater to pool in. And instead of just flowing off and washing away all the seeds and washing away more topsoil, it sort of pools and collects and actually sinks into the ground. So this replenishes the groundwater as well, makes everything much more habitable. This is such a big problem that in places like Africa, they burn down these grasslands, and in fact, in most farmlands as well, especially in Brazil, this was a very topical issue a few years ago when we were talking about the Amazon burning, and they used very, very specific wording. They said the Amazon is burning. They did not say the Amazon rainforest was burning. The Amazon is a state in Brazil, the Amazonia. It's just an area like Kentucky, like Western Australia, named the Amazon, right?
Yeah, it's a region. Yeah,
exactly. So it's a region, and so this was burning. Okay, well, no one ever said the forests were burning because they weren't. I'm sure there were some fires, but certainly nothing more than normal. What was burning, what the fires were that they were talking about, what they were trying to fool people into thinking was the rainforest, was actually farmland. So they were growing all these plant crops and so forth. They didn't have enough animals and things like that to sell this stuff to, because that's what feed goes to. 93% of all the animal feed, livestock feed that we use is inedible by humans. This is the chaff and the stalks and the corn cobs and the plant itself that we don't use.
So it would be wasted.
Yeah, well, yeah, it'd be thrown away in a landfill, or as happens in these areas, burned.
Yeah,
because they need to make room for next year's crop, so they got to burn all this crap off.
I mean, I was on a farm yesterday in New South Wales, and in the distance we can see this farmer burning a crop, burning what just looks like a field with some brown shrubs all over it. And we asked Charlie Arnott, whose farm we're at, and he's got a regenerative farm, do you ever burn off chaff like that? And he said, I haven't had to burn off chaff for 15 years. And since he started a biodynamic regenerative phase, as you say, the animals are eating that. That's nutrition that an animal can turn into quality protein and fat for a human to eat. That's,
exactly.
That's part of the cycle.
Yeah. And in the wild, it's even worse because, no one's going to be cutting this stuff down for animal feed in the first place, but there aren't enough animals that they've gotten rid of these sorts of things for a number of reasons. I mean, they Zimbabwe, actually, Allan Savoury was part of this, and he's something that he said will haunt him till he dies. But, he showed using the old thought that animals hurt the environment and animals cause deserts and so forth, that because there were so many elephants, this was causing the desertification of Zimbabwe. And so the Zimbabwean government actually sanctioned the killing of like 30,000 elephants in like the 1970s. And what happened? The deserts got worse. Okay. So, and they proved it. That's what they said. That's what he said. I proved it. I proved that this happened. And yet the opposite happened. And so it's not exactly proving. It's just, it's a supposition. And, as I've said many times, it doesn't matter how brilliant your theory is, and it doesn't matter how smart you are. If it doesn't agree with the experiment, it's wrong. And he's admitted, he's like, I was wrong. This was a bad idea. And he loves elephants, and he's just going to be haunted by that forever, as as it would, because that's a very horrible thing to have done. And it made it worse. So in Africa, when they burn down these grasslands, these grass areas, to make way for the next year's plants so that these things don't turn into deserts, they actually produce, for every hectare of land burned, these grasslands burned, it produces more pollution and more harmful pollution than 6,000 cars do in a year.
Yeah.
Okay. Now realize that just in Africa, I'm not talking about all the different farms all around the world and all the different grasslands that they're trying to do this to. Just in Africa, they burn 1 billion hectares of these grasslands a year. So that's the equivalent of 6 trillion cars emissions every year.
Madness, complete madness. I think that highlights one of the key themes that we talk about, Anthony, the interfering. It's like whenever humans think they're too smart and try and interfere and trying to muck with the natural sequence of things, whether it's central banking or whether it's exterminating elephants, which have been there for thousands of years, or releasing cane toads into Australia, whatever it is, or making people eat fake meat. I mean, this is interfering. This is it's arrogance. What you think your little theory is going to fix nature? You think you got control over nature? I mean, seriously.
Yeah. Well, it's it's a law of unintended consequences. When you start fiddling around with very complex systems, things that you would never have predicted are going to happen, and they're going to get a lot worse. And people, I'm just sorry, you're not that smart. No one is. You're not going to account for all of the trillions and trillions of interactions that happen every single day, every single minute, around the world. We're talking about the most complex system that exists, which is the entire world, right? As far as our world is concerned, obviously the universe and going from there. But the most complex system on Earth is the Earth, okay? And we're just saying, oh yeah, we're going to change this one variable, and that this will make everything better. We'll call it, CO2. They're really going after that. But even in Al Gore's movie, what is it? The Inconvenient Truth. Yeah. He said specifically, if you don't consider water vapor, then CO2 accounts for 30% of the greenhouse effect, and that's very serious. And then you start talking about, all the ramifications thereof and why, and this is why we need to bring it down and so forth. But the obvious question there is, well, what if you don't ignore water vapor?
Yeah.
How much really there? Yeah. Well, how much of a percentage is that? Well, and why are you ignoring water vapor? What does water vapor do? Well, water vapor accounts for 90% of the greenhouse effect, right? These are clouds, this is humidity and moisture and so forth. 90%. So you really cannot omit water vapor unless you're being dishonest and trying to sell something, which is exactly what he was doing. He's the first green billionaire. He used all of his political connections to push through things like Solyndra, which were a huge boondoggle, spent hundreds of billions of dollars on these sorts of travesties that were just completely wasted money and really harmed the environment in many, many different ways. And he profited from that directly. He invested heavily in all of these sorts of things, and he earned over $1 billion just by doing that. And so
the money.
Yeah. And so, I mean, God knows if that was his primary objective. I think that he was using that as a platform just to get power in the first place, because that's how he, I think his father was a senator. And so he already had a leg up in that regard. But then he wrote a book talking about climate change and CO2, all that sort of stuff back in the day, from, I forget the guy's name. He was a very, very famous climate scientist. And he took this class and he said that he was this guy's protege and they were so close and this, that, and the other. And he learned from him and it was such a wonderful experience. And, they asked the guy later, I was like, do you remember this guy? He's like, I have no idea. I had no idea he was even in my class. And he was a D student. He got like a D in the class. So like a D or a C, anyway, shitty grade. He got a really bad grade in the class. And then he just staked his entire, reputation on this, wrote this really crappy book. And that sort of, popularized him in the field. And he's sort of been harking on it since then. And
it's propaganda, isn't it? It is propaganda.
And he was quoting his professor's work and basically saying that this is coming directly from this great climate scientist and he ended up, I really wish I could remember his name, but he was saying like, never said that. Don't believe that. None of that's true. All these sorts of things. And then, the bastard like vilified him and just, dismissed him and said, no, he's just older now. He's just gone a little bit senile. It's really sad, for this great man to have fallen so low. It's just like, you're a dick, that you're absolutely misrepresenting this guy's work and his opinions. And now you're dismissing him as a senile old coot just because, he's called you out on it. That's disgusting behavior.
Yeah, horrendous. Yeah. So, I think that if we ignore the water vapor, that's a bit, Naval has a quote about money printing. And it's like, if we ignore this pesky thing called inflation, well, we can just money print forever.
If you ignore the bullet, then guns really aren't that dangerous.
Yeah, exactly right. It is madness.
How much damage is, some pistol whipping you're going to do? I can do more with a bat. So obviously if you ignore bullets, then, what are we really talking about here? It's nonsense, of course. And it plays a part into all of this, greater propaganda. I don't know what the reason behind all this stuff is. I don't even know if there is a reason. Probably money is the main one. There's a lot of money invested in all the, plant agriculture and so forth. And people want to protect their investments. And now they're pushing for, getting rid of meat and so forth, which I don't really understand. I don't think that necessarily has a profit model behind it, because these people can certainly invest in livestock just as well as they can invest in plant agriculture. So it seems to be something else going on there. What's that?
I don't know. When I sort of look at it, I see a lot of these plant-based products have huge margins on them. And
true.
Yeah. And producing animals is expensive because you've got to have quite a lot of land and resources. Whereas with these plants, where all you need to do is you can have a smaller amount of land, a shitload of fertilizer, degrade the land for 10 years, but you can, pump out these pea protein products that cost, 10 cents to make and you sell them for $1. So I think that
it could be,
there's short term, there's a lot more money in this fake food, plant-based stuff.
Yeah. And either way there's something going on there. From a nutrition standpoint, I think that we've sort of, banged the nail in the coffin on that one, and we'll continue to do so and keep banging that drum. But, there's some sort of push here, to vilify meat and to push plant agriculture. But, a lot of these things are profit driven or power driven, like in the case of Al Gore. But it's a bit ridiculous, because you can have both, and there's if you look at the globe as a whole, obviously 2/3 of the planet is covered in water, but of the dry land you have 4%, which is arable, right? So this is where you can make grow crops and so forth. But this actually competes for cities. This is flat farmland, right? Like where do cities pop up? They grow up in previous farmland because it's flat and accessible. So that's a finite resource, and again we're losing tons of topsoil as well. So then you have rangeland, which is about 15% of the Earth's surface, right? So that's a big chunk of the dry land. Well, that's like, hilly, grassy areas and so forth that you really can't grow farms, and you're not really growing any cities because it's not.
What could we put there, I wonder?
Yeah, exactly. So yeah, you can run that. This is herd land. This is exactly where cows go, and sheep and so forth, horses, whatever you want, animals anyway. And then 10% of that is forest land, which you can also run animals through. You can also run herds of livestock through. So you got 25% of the Earth's surface thereabouts is suitable for livestock. Only 4% is suitable for plant agriculture, and this competes with cities. So, if we're being serious about this, we have to realize that animals are an extremely important part of our food chain. Most simply because it is our primary, most optimal food source, but also because the majority of the land on Earth can be used to raise livestock and raise animals, whereas
while caring for the environment,
and while a smaller and smaller and smaller portion of arable land exists for crops, and again is being damaged by those crops and the type of agriculture we do. We're losing topsoil, we're losing nutrients, and animals replenish this and revitalize it. And the only reason that we have plant agriculture is because we have livestock agriculture as well, and this is where we get fertilizer from. I was speaking with Dr. Ballerstedt the other day, which is something I'll post, but he does great work in this field. He's an actual scientist in this field. He's a PhD in forage agronomy, has a degree in animal nutrition.
Yeah, I'd love to say that.
Yeah, animal nutrition is an actual scientific discipline, unlike human nutrition, which is just crap. It's just epidemiological nonsense in human nutrition. But that's simply because you can't do long-term randomized controlled studies looking at taking genetically similar populations, putting them in identical situations and changing one variable or another. You can't do that in people. First of all, it'd be completely unethical to separate people and just raise them in a lab. Second of all, we're talking about an entire lifespan, right? And we're trying to see what happens to these animals over a lifespan. So how are we doing that with people? Like, good luck. You start that today. I guess we'll see you in 2200 AD, and with the results, that's great. I'm really looking forward to that. With animals, you can do this in a couple of years, and you can see exactly what's going on. And you have thousands and thousands and thousands of actual data points, and so it's an actual science, unlike nutritional epidemiology, which is more religion than science. But he goes through this, and he said very clearly, you cannot have plant agriculture without animal agriculture. They coexist and necessarily. And so, we're getting like the fertilizers and so forth from animals, from the manure, from the urine, but also from the blood and bone. There's an actual fertilizer called blood and bone, and this is what it sounds like. And so
that's what plants feed on.
Yeah,
I mean, if you want to have a healthy plant, you got to feed it dead animals. I mean, surely that just counters any vegan argument,
Yeah, when you go in the ground and you fertilize the ground after you die, that's just a part of life. It's part of the life cycle, and animals and plants are all involved in this.
On this course that I was doing over the last 2 days, we learned how to make fertilizer, and one of the ways you make fertilizer is you get dead animals, roadkill, and you put them in a bucket of water, and then you put a brick on them so that they're fully submerged the whole time, and then you let it rot for a month, and by the end of it, like, there's hardly any bones left, like it's all just mush and it stinks. But the plants and the grasses go absolutely wild, and I mean, dead wombats off the side of the road, they weren't doing anything anyway, but they go back into the land.
And and that's just what we've touched on in other talks. Living things have things that are good for other living things, and this is why you can get nutrition from plants. Obviously, there are nutritious things in plants. This is why animals eat plants, and while we can eat plants and we can get some nutrition from that, there are also other things that cause harm, but they're living things, and they have things that are good for other living things like us. But they have bad things as well, which is why, I don't touch them. But the reverse is true as well. we have nutrients. Those same nutrients are actually really good for the plants. The plant wants those too. And the plant wants our CO2. The plant wants our blood and bones. And, on the CO2 thing, if you just think about it, the flowering plants that exist now evolved in a time where there was 10 times the CO2 level. Okay. And as we're talking about, the jungles in Pangaea, the supercontinent, where there's just massive dinosaurs and jungles and all these sorts of things. The earth was teeming with life and diverse life and so forth. And these massive animals, were able to support massive forests and jungles and grasslands and so forth. So now we're actually getting to the point where the CO2 level is actually getting dangerously low. Just before the Industrial Revolution, the parts per million of CO2 actually became below 200. Now, you have to realize that flowering plants will suffocate and die off if the parts per million of CO2 goes below 150. Okay, so you get the parts per million of CO2 in the atmosphere below 150 parts per million, you will have a mass extinction on your hands of these flowering plants and all the animals that rely on them as well. And you take you screw with a complex system in a little way, you're going to have big problems. You do it in a massive way, you are going to have a catastrophe on your hands. And this is what we see, in all the the records of mass extinctions, like an asteroid hits or a volcano erupts and pops up a bunch of, dust and ash and things like that into the atmosphere, which is, something that Bill Gates is trying to do in Sweden for some reason. And you get mass extinctions, and all these plant lives die off and all the animals die off. And you have huge tracts of life going extinct. And this has happened multiple times, but it will happen again if CO2 goes below 150 parts per million. So in fact, we're actually going way too close to this for comfort. And then the Industrial Revolution hit in, and now all of a sudden it started going back up. And it's not a question that there's anthropogenic changes to the climate and changes to the environment. There absolutely is. There's no question about that. The question you have to ask is, what effect is it having? Is this a catastrophe? How much of an effect is this having, and so forth. So those are the real questions. Yes, it's happening. Of course it's happening. We have an effect on our environment, but what is that effect? Well, one of the effects was that the CO2 went away from the dangerous levels of plant extinction, and now plants are able to breathe more. They have more CO2. And so what happens then? There's more plants now. Okay. And the Sahara Desert, when looked at from space, is green for the first time. And now we're having just so many, plants are growing better. They're growing more abundantly, they're growing easier. And this is actually helping, feed, the world population that is heretofore starving. So it's actually making it easier to feed the planet and to wipe out starvation and so forth because of this. We have greenhouses that we pump up the CO2 to like 5 to even 10 times what we see outside. And this makes the plants grow, like 4 or 5 times as fast. It's better for the plants. And so we're actually seeing that. Oh, and just to touch on the Sahara Desert, one of the reasons we know that the Sahara Desert is quite recent is because we have infrared imaging from satellites looking down, and we actually see like settlements and things like that, and the bones of buildings and structures and towns and cities and so forth all throughout what is now the Sahara Desert. And the Sahara Desert's growing; it's continuing to encroach on the rest of Africa, and so this is a growing problem, and this is sort of just buried a lot of other civilizations under its yoke. But that's the thing. And so CO2 levels have actually gone up a bit away from this dangerous level, and that's actually benefited the plant. That's benefited the plants. That's benefited the environment. So
this is the exact opposite of what we're being told in the media.
Yeah, there's a saying. This is something that I've looked at quite in depth as well, and it's all coming from climate scientists and physicists, Nobel Prize winners, and so forth. There's there's the guy who's a professor emeritus at MIT in meteorological physics and so forth. I mean, this is exactly what climate science is, and he has talks that he gives on YouTube and so forth. He's been in front of Congress. There's Willie Soon. Dr. Willie Soon is a professor in this. And, there's this stuff is out there, and there's these experts out there. The idea that, all the experts agree in this thing, that no one agrees on everything all the time unless you're in a cult, and certainly not in the scientific disciplines. One of the physicists, Nobel Prize winning physicist, Ivor Guyver. Yeah. He's an expert in superconductors and so forth. And he just showed the science of all this sort of stuff. And, he made the point that the Physical Society of America, that deals with, physics and so forth, that they still to this day argue over the weight of a proton, right? But this same physical society made a statement saying that climate science is indisputable, it is settled, and we will hear no dissent, and so forth. There's like, you have to toe the line, and so forth. It's like, if you can argue over the weight of a proton, but you can't argue over the most complex system that exists in our reality, is
esoteric and impossible to measure.
Yeah. So, these things are wrong, but of course this doesn't really make mainstream news. But neither did carnivorism, neither did anything that we're doing here. And I think that the contrarian nature of people that have looked into, say, diet, nutrition, and seen that a lot of this stuff was based on disinformation and sometimes outright lies. You start looking for this stuff.
Yeah, I agree with that 100%.
And so you start thinking, you're like, okay, and then you start seeing and making very, very strong fact-based, evidence-based arguments. There's Freeman Dyson, who I mentioned, one of the most famous mathematicians alive, certainly who's alive, one of the most famous mathematicians who's ever lived, certainly from America. Professor at Princeton, and held the Albert Einstein, chair in mathematics department at Princeton.
I tell you what we all need. We need a Anthony Chaffee reading list.
Yeah. Okay.
Or YouTube links. I'll start putting one together.
Yeah.
I've got Willie Soon and Freeman Dyson so far.
Freeman Dyson. Yeah. So he had some interviews and things like that on YouTube, which are great. You can just look up Freeman Dyson and climate change or something like that. Willie Soon is another one. I actually have these lists because I keep all this on my phone. I have all the lists of all the different sort of carnivore related things, or all the different sorts of studies and so forth that I find interesting. I just sort of collect all these. I've done the same for this as well.
Yeah, cool. I want to see it
and so forth. Yeah. Well, we can link a few of those as well. If people are interested. If they're not, then don't worry about it. But this all plays into the greater discussion about, people say like, okay, well, I concede the point that, animal-based nutrition is best. Let's say that's true. But we have 8 billion people on this earth. How can we possibly do that? This is going to destroy the environment and so forth. And the point is that no, it's not. And that we've again been misled in this arena as well. And that there is copious amounts of evidence and hard science, and I mean hard science. I mean this is physics and math, in its pure raw state. This is not like some epidemiological study. This is real stuff. And there was a lot of cover-ups with the hockey stick with the hockey stick graph with who's that fraud's name? I don't know. Well, he'll probably sue me. He sues anyone who says that anything disparagingly about him. But he's got a bunch of court cases and things like that up, and he's getting his ass sued too. And there was a big cover up. It was called like Climate Gate, and this happened when I was in second year of medical school, and I remember this coming out. It was like the East Anglia Research Center. They had all these like thousands of emails got leaked, basically talking about, they're like, okay, well, we're gonna put the science into climate change, and we're gonna show one way or the other what's going on. They found this correspondence between the guy that did the hockey stick graph, which is fraud. I mean, you look back, the actual record is not a hockey stick. It was up and down and up and down and up and down and up and down, and then it's come up a bit as well. But it was always moving and always changing. Again, this is a very complex system. It's not going to stay static forever. Yeah. And so they found all these correspondence, and people can look this up. It's just a matter of record at the moment at this point. But they they were talking about how they were doing all these experiments, and they were like, oh, well, we're actually showing the opposite of what we want. We're actually showing that, all the stuff we're talking about with climate change and so forth isn't true. And so they talked about how to manipulate the data and how they're going to change the data and how they're going to misrepresent their own findings.
And this is all recorded notes.
Yeah, it's their own emails in their own words. This isn't somebody else's, account of what happened. This is them talking in their own words in black and white. And I guess no one ever told them that you should never write anything down that you wouldn't want to have read back to you in court, because now it's being read back to them in court. And it was. And so this was a big fraud, and it was a big cover up. And but of course the cover up got covered up. And so, when people came out with this, it just got stuffed under the rug absolutely as soon as possible. But it's there for anyone to look at if they like to. Yeah.
Awesome. Yeah, that's worth looking into. All right. Well, let's wrap there, Anthony. Mm-hmm. That was fantastic. I think we've definitely busted some myths. And we've encouraged people to go and do their own research and look a little bit deeper into this. Because there's a lot of bullshit around this topic, undeniable. And everyone needs to do a bit more research and come to their own conclusion.
And that's the thing with any of these sorts of things. You can get a study that concludes anything you want it to, but you have to look at the study itself. You have to, unfortunately, you just have to learn how to read studies and read the methods and see the results and so forth, and say, okay, does the methodology and the results support the conclusion drawn by the authors? And then see, like, okay, but they're not providing data, they're not providing this, which is what the hockey stick guy would not just refuse to supply any of his data. And big red flag. And you see, are they being transparent? And do their methodology support this at all? Is this methodology even going to answer the question asked? Do their results support their conclusions? And you just have to look at these sorts of things yourself. Unfortunately, you just have to do that.
We all have to learn how to do it.
Yeah, I mean, you can trust people, but you are trusting them. People get things wrong, even very well-meaning people. Like, I don't try to mislead people or anything like that. I try to just lay things out as factually as I can. But I'm not going to get everything right every time, and I'm certainly not going to be able to see everything at all times. So I'm constantly learning and constantly reevaluating what I've learned previously. So it's important to do your own research as well. And because the thing is too is that maybe someone's very well-meaning or seems well-meaning, but how do you know? And maybe they're just sort of they've just got something wrong and they don't really realize it.
Yeah, I think it's common.
You need to sort of check these things yourself, and always, and never trust anyone who won't show his sources. Like, Jesus Christ, like that hockey stick guy, just will not show his research, will not show his data. Something's up. Like this should be like Allan Savoury, where this is reproducible and readily available. Said, if you do this, you should expect to see that, and they do it, and it does. And so that's something that can be trusted. But yeah, unfortunately, there's a lot of misinformation out there in everything, and we're just sort of scratching the surface of it with the nutrition side of things.
Well said. Awesome. All right, Anthony Chaffee MD. Until next time, mate. Thank you very much.
No problem. Thank you, man. Good to see you.
You too.